this is overall great. If anyone also have any question concerning this, go ahead and ask me now. I have already published the grade this is, which is the 15% grade. It will be accumulative, that it will be updated each week. There is now an option that I can download the attendance from the team. I talked with the IT department before this was not activated. Now it is activated, so I can download it. No need that you can write present. So if anyone has any concern of this, I will recommend that you double check, because at the beginning we were collecting it manually, so maybe there was some mistakes. I received some email about this, and I updated the record based on the emails. I have to go to double check again to see the team. But if anyone still has any concern about this, just double check it and be back to me. So today, there is still a small part concerning referential integrity, concerning the DDL part that we have already mentioned in lecture 4. And we should today finish the last part in database design. The next step after this lecture, it will be that we start learn about SQL queries, that SQL queries that DML, which talk more about manipulation of the data, how we can do this. To do this, we need also to learn something we name it algebraic query. Starting in the next lecture, we will do it. So today we should finish everything concerning database design. And I think so we have a project in the syllable, if I remember. Yeah, and it will be group-based. We will discuss it not today, the next week. After I will distribute you into different groups in the Blackboard. So I think so after we finishing the database design, you can start your project by designing the project. And then later, when we learn more about SQL queries and how we can insert, select, and update, delete data from your project, then you can go ahead and apply this. But since we finish a main part now in this course, I think so you are able now to start the planning and working in the project. So starting next week, I will publish some project some rules concerning the project, and we will discuss in the next lecture. Go ahead, Josh.
Yeah, I was just curious about the project specifically. You're saying you're going to be assigning it in Blackboard. Will we be able to select our own partners, or will that just be randomly assigned?
It will be randomly, but in case there are some special cases after I distribute you, or if you want to do it now, if you have already a group, even though I don't recommend it, I recommend that you work with groups that you don't know them, just to kind of benefit from others that you don't know. And it will be a good opportunity how you can build your own group, even though for people that you don't know before. But if there are any concerns, some people they have some concern, they still send me an email. I will consider your email. So Josh, if you have any concern concerning the group and you have something you prefer, please send me an email today, telling me about your preferences in this. Okay.
Well, my main concern is ending up in a group with some people that might not contribute as much, because I've had that a lot in comp courses in the past. So even though I don't know most of the people in this class, I can tell who's actually contributing a lot of the time. So I'd prefer to pick
Yeah,
people
but still,
that,
but if you are saying that, I know some people that contribute, but maybe also still there are many people who are here that you don't know, but they can also contribute. Is it correct, Josh?
Yeah. Some
I
of the
will
time.
I will tell you something about the project. Maybe let us discuss it next week, but I will tell you something hint about how I'm going to deal with this. Normally, when you have a project, suppose you will be 3 person. You will have one person, he's working so much in the project, and you will have other person who will take care about about the management who had the leadership skills. And you have another person, it is not always the case, but many times, that he or she expects from the others that they are going to work. So the third one will not make an effort. What will happen now? That I will not give any grade, even though it is an online course, without presentation. And in the presentation, it doesn't mean that you are in the same group, you will get the same grade. This happened before with me, that I give a grade, a full grade from somebody in the same group, and some other people get a low grade. Because based on the presentation, I can ask about anything in the project. And in this case, what will happen that all groups, this is what I will tell for the groups, all groups should expect that you'll be asked questions about the project, not only from the part that they claim that they have already worked in it. So this will give motivation for all people to contribute, because if you don't contribute, and then you are going to be asked many questions and you can't answer, and in this case, you'll get a low grade. Ivan said, this sounds like a real technical job. Yeah, one manager, one actual developer, and the other would be the secretary one in this case. So Josh, go ahead.
Yeah, I just wanted to add to that point. How do you handle a situation where somebody just memorizes what they did and just somewhat follows along, even though they don't put any work in? Because I've had groups like that as well.
This
where
is
you have someone that does nothing.
Yeah, no, don't worry about this. Being given being given courses 10 years, so I can understand from the first question I asked the student, from his or her reaction, I can see that he or she doesn't work in this. Yes, no. So normally people who doesn't work or just memorizing what the other told them, they will not have a self-confidence in the way they will ask the question, the reply to the questions. So I can feel it, I can see it, and this is the main aim from the presentation. So if there is no presentation, no grade. Presentation is a must, and it would be a live presentation. So we will book another. It will not be the same for the lecture if we are okay with the course material. If not, then we will book another lecture time or another meeting time it will be just for presentations. And it is a must presented. And as I said, high percentage from the overall grading will be based on the presentation, not only the report. And Josh, this is an advice for all, not only for Josh. The aim from the project is not only to practice, because I know many people have problem with the teammate work, and this is very important later when you go to the job market. So we should be more familiar as a team how to can work with each other, because it's extremely important in the job market that you know how you work as a team. So another objective for the group, not only to practice the course material, and also to train yourself how you can work within a group, even though sometimes you should adapt yourself the way the other is going to behave in this. However, all people who will be in the same project should have a main motivation that they need to have this as a successful story, because this will affect the overall grading for all people here. But again, if there are some people doesn't work and some people has already worked, and sometimes the performance of the project was affected because there are some people who are not working, I should consider this, even though I don't have a high outcome. But if during the presentation and the questions, I see that a person has a huge contribute, but because he or she is working alone, he can't, or she can't, or they can't do it. In this case, I consider this as a grading. So I will try my best to be fair with all of you here. And again, this is the main aim from presentation. Are you okay, Josh?
Yeah, more or less.
And if you have any more concerns, just drop me an email, or you have some names in your mind, just drop me an email about this. Okay, let's start with today's lecture. So let's say first where we are in the course. So if you remember, we said at the beginning that database design have three different phases. The first one is a conceptual, where we talk about how we can design the different concepts that we have it and their attributes and their relationship. It was using ER diagram. The second one was logical design, is how we can use a special well-known data model to use it to formulate our database or structure our database based on this data model, where we make the relational schema here. And then we said, now we have the relational schema, we can go to the physical implementation. We go to the physical implementation, we use DDL query here. DDL SQL query, how to write this. So, however, there are still two parts from the DDL query we should consider it about referential integrity. And at the end, we are going to talk about, not at the end, so it will be the main lecture about normalization. Normalization, some people see it that it is an enhancement procedure where you should consider in this enhancement procedure about if you have now your database structure. I'm not talking about the data in the database. And is it the correct or the optimal structure to do it? It's more like an evaluation for the design. Some people who give this course, or if you go double check online courses, they will see that normalization should be at the end of the course. However, I see it that should be now done as apart from before we go to start learning DML SQL query, to be sure that the database design that you have it now is the optimal database design or the mostly likely optimal. There's nothing optimal because the mostly likely optimal in this case. So we'll talk about referential integrity constraints today. And then we'll talk about normalization, what is normalization database design and relation with the normalization database design. And then we talk about the 4 different normal forms that we should consider in this course. Sure, we will have some group work exercise. So let's start with maintain referential integrity, how we can maintain this referential integrity. So when we talk about referential integrity, we talk more about foreign key. You are aware about foreign key. What is a foreign key? Why we need a foreign key? So anyone can give me a definition what is a foreign key? What is a foreign key? You should know about it. You finished the midterm about it. Go ahead, Josh.
Foreign key is used to refer primary key.
Who's talking? Just Asira, because Josh has already raised his hand. Josh, do you accept Asira that talk about this?
Yeah, that's fine.
Go ahead, Asira.
Foreign key refers to the primary key of a table.
The first primary key, sorry, can you say? Yeah.
Primary key of another table.
Yes, perfect. Thank you so much, Asira. Yeah, that's correct. So a foreign key is a copy of the primary key of another table. And normally we have to do this to keep this integrity between, or there is a relationship between a table X and the table Y. So because of this relationship, we keep a copy from the primary key as we name it as a foreign key. What we did the last time that when we talk about this is how we did it. That when we define a foreign key, we said this is a foreign key. We give the name of the key here in this table, and then we make references from which table it will come, and the name of the attribute, how it was in this table. When we said our foreign key can be one attribute or more, it depends. And we can have more one foreign key in the same table. It depends about this relation, how many relationship it has in this case. So, but there is a big question here. Is, for example, now we talk about table thought here. And we have a course called a foreign key from table course. So this is a foreign key from table course. So this is a foreign key here. As we can see here, this is a course code, a foreign key. And it is part from the primary key, but it is a foreign key. And it refers to this primary key in this table. So suppose you have a course name code 230. COM 230. The name is COM 230 or whatever it is called 230. And since it is a copy, so the course code in table taught will have 230 as a record. And then the university updated the course code for different courses. One of them was COM 230. And now in the table course, it is 230. Now it is not anymore 230. It's now 250. However, in the table taught, it's still 230. So what we are going to do in this case? Do you want me to repeat the question or you are okay with it?
Repeat the question, please.
Yeah, the question is, so let's take this case. We have table taught. This is a foreign key here. And we have this is as a primary key here. And this refer to here, according to what we are writing here. So far, nothing new. What happened that in this table, you will have different data. You will have, for example, code here, course name here, and a credit here. And then you have 230 comp or database, credits 3. And since in the table taught here, you have also course code, semester, professor, SSN. And then, since this was a copy from here, so you have this also here, 230. Semester, fall, SSN, 111, whatever. Now, you as a university management, you change the course code. So it is now database will not have any more 230, it will be 250. And normally it will be changed in the table course. What will happen to 230 here? What we are going to do with it, this one? Because now 230, who's now in this attribute, is not anymore related to this. Even though it's still related, it's talk about the same course. But here say 230, here say 250. Because the course code was updated in the course table. There is inconsistency in the data now. So any solution for this? Or we should consider this when we talk about database? What do you think? Any clue about this? Go ahead, Josh.
So if we're talking about SQL, would it not update the other table as well if we change one, since it's referencing that variable? Or
yeah, because in the SQL now we said for the SQL okay, Samran and Nassan, we have something, we will discuss it now. So first, Josh, according to the codes that we are writing here, we told the SQL compiler, hi compiler, this is a foreign key here, that's all. But we didn't tell the compiler about whenever we have a data being updated in one place should make a coherent with the data, nothing being written here. And this is why we should add a part to our code to maintain this referential integrity. Nassan said we will get an error, so when you update, you should have done the primary key first. Yes, and I will tell you what is the default. We will not get an error. We need to update. We need to update taught table 2. So, yes, this is what we should, and what Nassan said that we should update in both or get error. The SQL compiler, if there will be a default action, which is in this case, there is no update is allowed because it's being related to each other. So update will be refused. This is why if we need, whenever, not to refuse the update, we need sometimes if an update happen in one place, it should be happen in the other place. And if an update happen in one place, either we'll make the same update or we will delete the old data because it's not related anymore. So there is more than one option we can do with this. Cora, go ahead before I go to the next slide. Cora.
Sorry, I just click it.
Sorry? It was a mistake?
I just click it.
Don't worry, it's good we hear your voice today morning. So if we now we go, so as I said, action prevented by, so we try to delete a tuple from the course where it can appear in the course, and course it will be prevented. We try to update, it will be prevented because it is these two attributes, they are related, one primary, one foreign. So, however, so the default policy will be reject modification, but this is not the case because we need to make a modification. So there is something we name it cascade policy, which is automatically apply modification to the foreign key. So if the primary key is being modified, which is the foreign key is a copy from this primary key, sorry. So automatically update. This is the optimal case. Or set null, which means that if it's being updated there, still accept update and make it as a null in the other part in this case. And this more we use it when we will delete, not update. Or we can mix both in this case, one we use it for delete and one we use it for update. Let's see an example. This is an example here in this case. So I didn't share with you this because at the beginning I want to understand more about what is a foreign key. Now I want to share with you this. So in this case, I will say, okay, so the primary key is this. The foreign key, as we have already done so far, nothing being changed. When I will create the table told, I will say, okay, now this is a foreign key coming from this table. However, on delete set null, on update cascade, here I can use also on delete cascade and on update cascade, which means that if you will update the primary key, go ahead and update it in the foreign key. For the code, if you deleted in the primary key, like 230 you deleted, not updated, deleted, now set null. So 230 in the foreign key will be null in this case. I do this because sometimes the other data, because you know when I will delete a record, I can't delete only one attribute. I have to delete the whole row. So rather than deleting the whole row in the foreign key part, I said just put null for the foreign key and keep the other record. However, I can still use on update cascade, which is, and if you update it there, update it here, if it is 250, 250. If you delete 230 in the table course, then also delete the whole record in the other table, which is in this case, the toad table. Go ahead, Josh.
Yeah, this is just a quick question about the code itself. When we do code int and then we say references right there, can we still do this? So if we do it,
Yeah. The way you,
Okay.
the way you declare, yes, still you can use one of the two ways that for the foreign key in this case. Yes.
Okay, sounds good.
But here we just add 2 lines concerning maintaining referential integrity to tell the compiler when there is an update or delete how it works with this. Because I said that the default will be rejection of the update. And this is not the optimal scenario that we seek for, because we need to make some updates sometimes in our database. So again, in this case, when you will create the table with this a foreign key, it is highly recommended that you consider the referential integrity maintaining, which is in this case on delete or on update, as I did here. So if I have already this constraint, which is about this a foreign key, and on update do this, on delete do this, on. So still I can modify it, yes. Still I can modify it as the same like as we did before when we talk about DDL query. When we talked about DDL query, we said, okay, we still can modify our structure. So now if I add a constraint, which is how to deal with the foreign key, still I can modify this constraint. How I can, so this is why it's better there is something more added to give a name for the constraint. Because normally, especially when we talk about foreign key, it is highly likely that you will have more than one foreign key in the same table, not only one foreign key. So in this case, it's better that for each constraint concerning this foreign key, like saying this is a foreign key and on delete do this, on update do this. So this is all we name it as a constraint. So this is a constraint, and this is another constraint. So it's good that when I structure my table, when I implemented my table, that I give it a name, the constraint fk1, constraint fk2. So I should have already give it a name. What would be the name for this? It's very important that I consider the name for the constraint. Why I have to do this? Because later I can go ahead like here and said, okay, you as SQL, please alter table as we did before, and said drop foreign key fk1, or can drop the primary key. We have already done this. So because if I said drop foreign key, which foreign key now would be? It be both. So this is why when I constructed, especially when I have more than one foreign key, it's better for this constraint to give it a name. So I said, okay, go ahead, drop foreign key, fk constraint. So not only to drop the foreign key and delete the whole constraint, which is on update, on delete, whatever it is. So this is another way. And also if I don't have already this constraint, like for example, now you have already created the table and you need to update, to add this maintain referential integrity constraint, which is on delete, on update. So you can make an add constraint as also alter table, add constraint, name the foreign key. But if you have already the foreign key, in this case, it's better to drop it and then add the constraint again, add a foreign key again. Plus, you will add the maintain referential integrity constraint in this case, like on delete cascade, on update cascade. As I said, the foreign key should be added as a complete book, including delete and update. They cannot be added later separately. So if you have already created a foreign key and you didn't create on delete and update, in this case, you should delete the foreign key and add it again with this on delete and update cascading or maintain the referential integrity constraint in this case. This is just, I want to add it as a referential integrity constraint to be considered as a part from the DDL query. We are done from this. Any question before I go to normalization? No question. So I will download the attendance now here. I should be able to download the attendance. Download attendance list. So okay. So no question. Let me go to normalization. Anyone is, before I go, anyone is familiar with the word normalization? Maybe you have already heard this word, maybe in math, maybe something like this. Go ahead, Josh. What do you know about this word?
Just know it from math.
Yeah, so in math, do you remember what does it mean in math?
If I remember correctly, this was a while ago. It's typically when you would want to set something to be like a unit vector, I guess. So you would normalize it by making it the magnitude of it 1.
Okay, so good. In this case, yes, this is a good example. Simran, go ahead, please.
I'm sorry to interrupt you, Professor, but do we have to mark our attendance somewhere?
Sorry?
Where do we have to mark the attendance?
No, you don't have to mark the attendance. Just I'm able to download the attendance, so no need to make this.
All right, thank you.
Because now I have the option in the team that I can download the attendance, so all good.
Okay, thank you.
So in this case, as Josh said, so in math we use it to make a normalization for a vector, which is we use a normal vector which is a standard vector, which is in this case we have a standard vector and we can to use it as based on this standard vector we can make different units for any other vector in this case. So normalization here in database system, it's talk about the same concept, but not the same way for sure, which is, it can be seen that normalization, which is the standard, we have a first, second, third, fourth normal. There, whenever you have a plane, you will have the norm vector. And based on this, you build your other vectors based on this norm vector. Here, for us, it will be different standard. Go ahead, Asira. Asira?
You mentioned like normalization is related to avoiding redundancy. I remember that you mentioned in the class.
Yes, that's correct. This is why we are going now to double check the redundancy for normalization. Thank you so much for this. Yes, so normalization in this case is based on different standard. We will have first norm, it has its own standard. Second norm, it has its own standard. Third norm, its own standard. And this normalization that have different standards, I will say, okay, does this database comply with this standard? Does this database fulfill the requirement for the first or the second or the third? If it fulfills the requirement, then mean this our database now, it's more standardized, and in this case, it has less redundancy. Because these standards talk about redundancy. The more standard, the higher standard you will have, a less redundant data you will have. So some people will consider normalization as a bottom-up standing alone database design, which means that you will go from bottom up, from what you have already to up, or a validation technique. I see it as a validation technique, which means that you finish your database, you have the relational schema, even though you have already implemented, you have a data being inserted, and now I need to validate to see if I have redundant data, yes, no. So as I said, and as Papa said, so we should validate our design to be sure that we have a good design in this case. Asira, do you still have anything, or you just stay? Because I see your hand still raised up.
No, sorry, it's
No worry.
I forgot to change.
So what determines a good design? So we said normalization will be used to determine if you have a good design, yes, no. So how we say we have a good design? As Asira said, that for us with a minimum amount of stored information and no redundant data. Minimum amount of stored relation. So, which means that you are not saving the data in different places where there is no reason for this. You are making a duplication, wasting time, and increasing your scale. When I said increasing the scale, it's not only because increasing the scale will affect the database storage that I have, and this cost. Because when we talk about online storage, and we talk about huge databases, in this case, we should consider the more scale we will have, the more complicated to analyze the data. The more time it will take to retrieve any data, because your system, rather than searching in 1 gigabyte of data, it's going to search in 100 or 200 or 10 gigabytes of data, whatever it is. So the more higher scale you will have, a more complicated and less efficient will be. So we should avoid making any redundant data or making any duplication for our data whenever there is no need to do this. How this will happen? So let's see how this data, what we mean by data redundancy and update anomalies in this case. So data redundancy means that information is stored redundantly, which means, as I said, it's being duplicated in different places, even though there is no need for this duplication. This will be waste for storage. And again, as I said, wasting the storage will affect also the efficiency and cause different update anomaly. Why? So suppose you have a data, we'll see it now, just I'll give you introduction now. So suppose you have a data here, this data about the student name and student date, whatever it is, date of birth. And maybe if it is a foreign key, you can do it, and then you make this function integrity results is okay because it will be automatic update. And normally it is a must to use a copy from a foreign key to put it in the primary, the copy of the primary key to put it in the foreign key to make the relationship. However, sometimes this will happen without any need for this. So you will have the same data here and the same data here and the same data here. And in this case, if you update the student name here, you will forget to update it here. You will forget to update it here because it is not like a foreign key and will be automatically updated. In this case, we will have inconsistency of data, and then we will have anomalies. This anomaly is based on when you will insert or modify a new data or delete it from a place you didn't delete from the other one. And this happens because you have a data redundancy. So data redundancy will affect the storage, and this affects the efficiency. And also, it will open the door for update anomalies because it's being saved in different places. And maybe if you delete it in our place, you should consider how to delete it in another one. Again, in the case where we have a foreign key now in the primary keys, it's okay because there is already some cascading procedure. Here, we don't have a cascading procedure. We don't have a primary and a foreign key. We have the same data being used in different places because I have a bad structure. So let's take this example. So this example here, I will have a table, I name it the staff branch. There is a staff number, a staff name, a staff position, salary, and there is a branch number and address. So whenever I have to mention the branch number, since it is an address, I have to mention the address. This is data redundancy. You are duplicating the data and no need to do this. So suppose that I updated the address of B003. I said it is not anymore Main Street, Glasgow. So it will be Main Street, Abbotsford. And have another address, 22, for example. So now I should search for all B0 to update this. I have to write a query and searching for all this. I can't update it in one place. And if I didn't update it in the whole database, what will happen that I will have B00 sometimes have this address and sometimes B00 have this address. Because there is no restriction that I should update in all places. It is not a foreign key and primary key. The problem was that why I have already, whenever I have to mention B0, I have to mention the address. Why? If I will restructure in this way, rather than having all attributes in the same table, I will have two tables. This is the first table, and this is the second table. And now, if I will put the branch number here, only the branch number, and I create another table where we have a branch number and address, this can be now the foreign key here from this. So now, if I want to change the address of B0, I change it in one place. And still I can mention for each staff the branch number. but I don't have to mention the address. So here, using this structure, having these two tables, I will have less redundant data, less redundant. And since I will have less scale, so I will, for example, I save it here 3 times, I here save it 1 times. And whenever I will update the address, I will not have redundant data because I updated 1 place. So this table structure, this structure is a redundant structure. How I know this, how I have to decompose it, this is what we are going to learn on normalization. But it seems so that decomposition was the solution for this. So normalization, it means that you have to validate or evaluate the structure based on a standard. If it doesn't fulfill the requirement of the standard or doesn't comply with the standard, then we are going to use this. We have to make decomposition in order that the new output will fulfill the requirement. So normalization, I can define it in this way. It will define different standards. If you want to fulfill the requirement, since it doesn't fulfill in any place, you need to make a decomposition. The output should fulfill the requirement of the standard that you are working with this. Any questions so far? This is another example. We have data redundancy and update anomalies here. So we have this table. And if we see this table, for example, when we talk about Star Wars years, length, and then we talk about general and studio name and star name. So always we are duplicating the same data because they are talking about the same movie. And we are duplicating these data, which is the same movie, because they're just only the star name is being changed. So it seems that the star name should not be here. It should be in another table, because having different star name for the same movie, I was enforced to duplicate the whole data of the movie, like title, year, length, genre, studio name, because I have a new record with a new star name. So in this case, I should put the star name in another table, not to keep them the same table. So now is this anomaly eliminated? I can say still there are some duplications that I can't avoid it. However, for a reason, I have a less anomalies, a less redundancy. Anomaly means that you have a less redundancies or less anomalies, because I said having redundancy in the data will open the door for anomalies in this case. So as Papa said here, we need normalization to pick the optimal decomposition. So what would be the optimal decomposition that we should consider here? How we are going to decompose? We need normalization in this case. So normalization is a process of decomposing unsatisfactory bad relations, which it had a bad structure, by breaking their attributes into smaller relations, as we did. So if this means that they don't, based on a special condition, we will do a more smaller relation, more decomposition till we reach the optimal standard that we are searching for. So Papa said to do this, to make this normalization step, then we need to study function dependency between attributes with the same relation. Pertaining to the example here, I said it seems that I have to put this is again, and this is again, and this is again, because I have the star name here. So it seems this star name as an attribute should not be in the same table with this attribute as a whole. So here, now the big question in this case, So knowing the relationship between the attribute or studying the relationship will help me to know that who should stay and who should I get rid about it. And this is what happened here. And this is what Papa is saying for us, that we should study functional dependencies. Who depend on who from the attributes. When we have already built the structure of our database, we study the relationship between entities. After we have already agreed about the entities and their attribute. At that time, I told you, be aware that Ivan team randomly signed me out. Strange.
Yeah, don't mind me. I'm just yelling at the wind because I was listening to the lecture and then all of a sudden it was like you need to sign out and back in. So I was just very confused and yelled at the wind there.
Yeah, no worry. Just since you have this in the chat, so in case I collected attendance in the same period, I forgot when exactly I collected attendance. So I will be aware about. Thank you for telling me about this. But this is strange. I don't know why.
I think maybe because like UFV's retention policy applies to teams. I don't know. That's random guess.
I don't think so. Yeah, but somehow strange. Yeah. So as Papa said here, so functional dependency between attributes within the same relation should be considered. Yeah, we are the third group member that we are talking. It's no, yeah, it maybe, Josh, yeah. It seems that they have an AI system here. They can analyze our own conversation. So I hope that we reach a point at UFV, we embedded AI system here. I am part from the strategic planning group. One of the suggestions for the next 5 years is to have some AI platforms integrated apart from our educational process. I hope that we can get this within the 5 years. I hope so. Maybe you will be graduated at that time, or maybe it will be a pilot project for this. I hope that we can do it. So we need to study function dependencies because at that time I told you when you create an entity, be aware that the whole attributes for this entity are talking about the same concept and they are somehow related to each other. But even though at that time, maybe we said, okay, actors can be apart from the moving relation. You thought this. And later, when you start inserting data and then you make a validation like normal, you said, okay, no, they shouldn't be here. But how to do this? We have to study something we name it function dependency. So let's see what is a function dependency. It's very important to understand what is a function dependency. So for us, a function dependency within the same table, the same relations. So we are now studying the relationships or the dependencies or the attributes in the same relation, in the same table. So when we talk about a function dependency, it can be between set of attribute and other set of attribute, X and Y. So it can be in a way that set of attributes from the X part with set of attributes from the Y part. I said X give Y, or Y dependent on X. So X give Y. You can read it from left to right or right to left in this way. So X give Y. X can be one attribute or more. Y can be one attribute or more from the same table. So X can give Y or Y dependent on X whenever each value in X should be related at most to one value in Y. But Y can be related for more one value. Let's take an example to understand it more. So we have this table. Employee ID, name, phone, position. So we have employee ID like this, E0045, Smith, whatever it is. Let's see the function dependencies. What is the relationship? Let's see first the first one. So let's take from this, the simpler one. So position, phone. This is the X part and this is the Y part. So if this exists, this is a function dependencies, then each value of an x should be related to at most one value on y. It can be related to another value. So position here the position. We have a clerk. Clerk is related to 1, 2, 3, 4. There is another value here, says person. It's related 9876, 9876. It is not related to another one. Lawyer, it's 1, 2, 3, 4. So now this is a function dependency. If this is, for example, here 7, now this doesn't exist anymore. Why? Because there is a value in X, which is salesperson, related to different values in Y. So it violates function dependencies. So function dependencies say that each value in X should be related to at most one value in Y. And if this value is being repeated, it's always should be related to the same value. So if we have 9876 once for salesperson, and then we have 9877 for salesperson, in this case, we don't have any more function dependencies. Let's take this example, form position. So form position, this is the X and this is the Y. So we have 1, 2, 3, 4, it gives a clerk. 9876, it gives salesperson. And 9876, that's good. Now we have again 1, 2, 3, 4, it gives lawyer. Now we have a violation because it gives sometimes clerk and sometimes lawyer. So in this case, this violate because it should only relate the same value to only one value on Y. Now this is X and this is Y. And here the employee ID. And if the employee ID, if the primary key, and then primary key normally, if it is a primary key, should always give the other non-primary attribute. Because first, the primary key is never being duplicated. So it always you have a new value. So in this case, this always exists here. Because we don't have a duplication, and when it's being duplicated, it should be related to the same value. Like here, phone is being duplicated. But when it's duplicated, in order to keep this is correct, we should have, whenever there is a duplication, having the same value. It should be clear here. But in the primary key, there is no duplication, so it's always exists. So there is always function dependency between the primary key and other non-primary attribute. So for us, a function dependency, X give Y, then each value of an X can be one value or more. Sorry, can be one attribute or more. Each value of X should be related to exact one value on Y. Why I'm talking about this? Because we are going to use it now. So if there is any question so far, do you want to take a break before we start with the normal forms, or you want to continue? If you want to take a break, so I need 5 thumbs up to take a break. Wow, many people want to take a break. Okay, so no, we will take 10-minute break. So I will be back in 9:45. So take 10 minutes, get your coffee, and we will be back after 10 minutes. See you soon. I'll just turn off my camera here and stop sharing. Hey. See, we stop here. Oh. So we are back. People are here. I need 5 thumbs up, not only 1. Okay. So, so now let's start with the normal form. So we said that each normalization would give us a special standard that we should fulfill. And if it doesn't, we don't have the standard, we need to make a decomposition that the output table will have the standard in this case. So normal form condition use keys and FDs for relation to certify whether a relation schema is a particular norm form, like can be first, second, third, BCNF based on key and FDs relations. And the fourth is based on the key and multi-value dependencies. We will talk about it later. So more restricted norm from the first to the fifth DKNF. However, this is very ideal. Sorry. Ideal. In reality, I think so. We will not reach a point where we'll be here. It's the more practical is to be here. But the higher level we will go, the more restricted will be. And in this case, the more tables will be. And now there are some complexity with the number of the tables that we are going to deal with it in the database. So you should make a balance about which is the desired level of normalization you want to be sure about it. And in the number of tables that you will have it. Because as I said, the more normalization form you will toggle or you will consider it, the more decomposition you will do. So let's start with the first one. The first one talk about more, it doesn't talk about function dependencies, about relations. It talk about only one restriction about multi-value attribute, or for example here, so we have this table, name, department, and then supplier, and then we have here location. If you remember, we said we have a multi-value attribute, or an attribute where we will have not only one value for this. And in the ER diagram, I told you to create a table for this. But if you don't do this, and still as a part from your database, that you have one of the attributes that can accept more than one value within the same record, in this case, it's not first NNF, which is not first normalization. In this case, you should decompose it like this. Decompose it, we have a department, we have a location. Department, you will have a name, number of department, and this is a supplier, social security number, or sub, whatever it is. And then we have the location as a standing alone table, and we will make a relationship between them if there is a relationship needed using primer and a foreign key. And I told you, if you remember, that whenever you will convert ER diagram to a relation schema, be aware that you create a standing alone a table for a multi-value attribute, if you remember this. So, but if you didn't do it, apart from your relational schema, and you keep it, in this case, we said you don't apply the first normalization rule, and you should decompose it to do this. Why it should be like this? Because sometimes if you, for example, you update a value here and you have a different values, so you should be aware that you update in different places. So now if you put it here in a one table and each one will have only one value, so now it's more clear to be less redundant in this case. So I think so first normalization, easy one to deal with it. Just don't have a multi-value attribute or an attribute that accepts more than one value in the same record. That's all. If you have this, then you should decompose it. Now the second normalization start talk about dependencies. Dependencies. What is dependencies? How are these attributes in the same table? They are related to each other in a place and we should keep them or we should get rid about some attribute. So there is now the concept of primary attribute and non-primary attribute. A primary attribute is a number of primary key or candidate key. Do you remember, I think so, once we talked about it, that, for example, you have a table here, you have X, Y, Z, W. Sometimes you said, okay, X can be a primary key. And sometimes you said, okay, X and Y both can be a primary key. And so X is a candidate, X and Y is a candidate, and then I choose one of them as the primary key. When I said primary key can be the least candidate key, I think so we have already discussed this in lecture 4. So here, when we talk about primary attribute, which means that the attributes that are apart from the primary key or candidate key. The second normalization said to have a second normalization, we should, there was something in the chat? No. So to have a second normalization, we should be aware that we have a full function dependencies. Let's take here, I think so this is, we have already talked about it, but here, this is what I'm searching for. So second normalization, if every non-primary attribute is fully functional dependent on the primary key or candidate key. Fully functional dependent, fully function dependent. What is a fully function dependent? Is mean that it doesn't doesn't depend on a part of it. It depends as a whole. Okay, let's take an example to understand more. So we have this table as a table. This is a primary attribute and this is a non-primary attribute, which they are not part from a primary key or a candidate key. And we have, this is as FD1. SSN, P number, give hour. SSN, P number, give hours. And now we have another FD, which is SSN will give ename. Again, the FDs, we will build it based on the data where there's a relationship between the attribute, as we have already discussed so far. When we said X give Y, mean that X is related to at most one value in Y. So now this is this FD2 and this FD3 violate second normalization. Why? Second normalization says that all non-primary attribute, they should be fully function dependent on the primary attribute, which means that they should be dependent in the whole primary key or candidate key, not apart from it. So the primary key here in this case is SSN or P number. So to be second normalization, we should SSN and S number, both of them. To have the optimal case, SSN P number, give all other attribute. And here we have the problem with the FD2 and FD3, how it is, because SSN alone give ename, this is FD2. FD3, we have a P number that gives P name and P location. FD2 and FD3 violate second normalization because we have non-primary attribute that depend in a part of the primary key, not the whole primary key. And here we have another two non-primary key or attributes, sorry, that depend in a part of the primary key, not the whole primary key. This violates second normalization because second normalization said should dependent in the whole primary key. In this case, we are going to decompose it in a way that we should get rid about the attributes that are involved in this one. Like for example, here, I will keep the employee name. So I keep SSN P number hours. Here, the employee name, I put it in another table because this is violate SDN. So, and here, this one, this two that violate, I put it on another table. So I have 3 tables now. Now, if I will discuss the 3 tables, we have non-primary attribute hour dependent in the whole. In this table, the primary key is SSN, and the E name dependent on this. Here, the primary key is P number, and then dependent on this. Normally, this is a rule. If the primary key is only one attribute, then it's always second normalization. Because again, the definition of the second normalization say that all non-primary attributes, they're dependent in the whole primary key, which is fully function dependent. So if the primary key is only one attribute, it doesn't have different attributes that by default that they will dependent in the whole primary key because we don't have no more than one attribute in this case. So if we take this example, you should tell me now. So we have this is of FDs we have. We have here 2 FD. The first one is SSN give these, and we have this give the other. Is it second normalization or not? Amen. I know, Amen. You are somehow confused. It is not an easy topic, function dependencies. I know this.
Yeah, it's not easy.
But we will do it. So
Um,
is it second normalization? Yes, no.
yes, it is.
Why?
Because the birth date and the address is somehow it's related to the SSN.
Okay, so can you tell me again what is the definition of SSN?
SSN is like it is their primary key.
No, sorry,
in this case.
what's the definition of the second normalization? What is the definition of the second normalization? Yeah.
The second normalization it uses the concept of FDS.
Yeah, so it uses the concept of FDS, that's correct, but what is the condition to say that this table fulfills the requirement of the second normalization? Based on the discussion so far.
Can you ask that question again?
So the question is, what is the definition of the second normalization based on what we have already discussed?
I know it consists of the prime attribute.
Perfect.
Yeah.
So it say that non-primary attribute, non-primary, should be fully function dependent. What does that mean, fully functional dependent?
It depends as a whole, not just a part.
Yes. So in this case, that if whenever we have any dependent, we should double check if this dependency violates this. So here, how many dependency we have here?
For
Ayman.
the SSN,
No, in general, in this table, how many dependency we have? We have two. The first one is this,
yeah.
and the second one is this.
Mm-hmm.
Here, the SSN will give all this, and here we will have this give the other two. So the first one is SSN. Harmandeep, I will be with you. So we'll give the other, and the second one, we have D number, give D name, and DMG RSN. Is it correct?
Yeah.
So we have to double check each FD. If one of them violate, then we don't have any second normalization. The first FD, SSN, which is a primary key, gives the other. So they are not dependent in a part of the primary key. The other one say that D number give D name and DMG RSN. Does it violate second normalization this?
Mm,
What do you think?
no.
Why? I'm asking you so much a question, I know this, but just to clarify it to the other. So I'm sorry if I'm doing this with you.
I know. Yeah. I mean, this is like really confusing because
Yeah, I know. So is this FD2 violate? What do you think? You can say, I don't know, it's okay.
oh yeah, I don't know.
Okay, so to violate mean that we have a part of the key that involved in this dependency. Do we have a part of the key involved here? D number, it is non-primary. This is non-primary, this is non-primary. We don't have a part from the primary involved here. Is it correct?
Yeah.
So in this case, it doesn't matter for us in the second normalization, because we should be aware that if there is a part of the primary is involved, and we don't have the case here. Is it correct?
Yeah.
Because what the second normalization say that all non-primary should dependent in the primary as a whole, which means that if we can say it in another word, that there is no part of the primary involved in this. Here we have the SSN involved, which is the whole primary, and we have a non-primary with other non-primary. We don't have a part of the primary involved. Is it correct?
Mm-hmm. Yeah.
Ayman, I have a silly question for you. Do we have a part of the primary key here? Can we have a part of the primary key here?
And the D number or the SSN?
So what is the primary key here?
It's the SSN.
So SSN can be decomposed to different parts? It has more than one attribute?
Yes.
SSN. SSN is only one attribute, is it correct?
Yep.
So SSN is the primary key, and the primary key has only one attribute. So we don't have more than one attribute for the primary key, is it correct?
Yeah.
So if we have the primary key is only one attribute, so it is by default second normalization. We don't need to have to look for the function dependencies, because it will never violate the function dependencies. It will never violate the concept of the second normalization, because the concept of second normalization is the case where we will have different attributes for the primary key. In this case, we should be aware that no part of this primary key is involved in the function dependencies, like the case here. We have two attributes in the primary key. But if the primary key is only one attribute, then we are sure we will not have any violation, because there is no part of the primary key to violate.
Okay.
Is it clear for you, Ayman, this?
Yeah, somehow.
If it is clear, can you discuss it again for us?
No.
Okay, I will stop here. I will go to Harmandeep, but I want something for you, Ayman. Tell me finally what is your understanding for second normalization.
So for second normalization, I've understood the primary attributes.
Yeah.
Yeah. So like so on the left side, it's the non-primary.
So the non-primary attribute should be fully function dependent on the primary attribute, which means that it should depend in the whole. There is no relationship between a part of the primary key with non-primary attribute.
Can you repeat that again?
Yeah. So there is no relationship between a part of the primary key with non-primary attribute. Like here, in this case, P number is apart from the primary key. Is it correct?
Yes.
Because the primary key is two attributes here, this and this. So what happened here, why it violate? Because part of the primary key, which is P number, was involved in a relationship with two non-primary attributes, and this violates second normalization.
Yeah.
Because it is not allowed that we have a relationship between part of the primary key with non-primary key attribute. We should have the case that only the whole primary key has a relationship. There is another violation here where the SSN, which is apart from the primary key, is involved in a relationship with the E name. And this is also violate because part of the primary key cannot have any relationship. The relationship should be always between the primary key as a whole and other non-primary attribute. This is why I said, if we have a primary key here as a one attribute, it always fulfill, because we will not have apart from this to have this problem that we face it here.
Okay.
So whenever you have a primary key with only one attribute, you can say directly it is a second normalization.
Okay.
No need to check the function dependencies, because since there is no part from the primary key, so I'm quite sure there is no violation would be done. It's more clear?
Okay, got it. Yeah, it is.
So can you give lecture next time about this?
Yeah, sure.
Okay, thank you so much, Ayman.
Okay, thank you.
Okay, Harmandeep, go ahead. We want to hear you.
Did you said that example 2 is the second normalization?
Yeah, this is what we were discussing.
But D name and what this last is, it depends on the D number, but D number is not a primary key.
Yeah, that's good. So the second normalization said that whenever there is a relationship between the primary key and other non-primary, mean that it should be a relationship between the whole primary, not apart from this. But it doesn't say that there is no relationship between non-primary each themselves. It doesn't say this. This is the third normalization will say this. This table, it is second, yes, but it is not third. We will discuss it later. So second means that any primary key should give a relationship, but no part of the primary key, like what happened here, should be related with non-primary. But doesn't say that non-primary can be related, yes, no. Still non-primary can be related to each other. You got it?
Yes, thank you.
What happened here that these two attributes, they are related to D number. And D number related to this, then they are transitively related to this in this case.
Yeah.
So X give Y gives Z, then X gives Z. So what happened here that we have this is related to this, and this related to this, then this is now transitively, indirectly related to this. But again, for the second normalization, we should be aware that there is no relationship between part of the primary key and other non-primary. It is not allowed. any relation should be with the whole primary key and any other non-primary attribute. This is why here we decompose it in a way that there will be a relation with the whole primary key with the non-primary, as we see here. Is it clear now, Harmandeep?
Yes.
Okay. I will take another one. Ivan, don't tell me now you are kicked out from the team because I will ask you.
I'm not here.
So Ivan, is it clear for you what is a second normalization?
Yes, I believe so.
So
You want me to
this
like put it in my own words, or?
Go ahead.
I mean, I guess I don't really have anything new to add. Yeah, the primary key is there, and every attribute is every non-prime attribute is only dependent on the primary key. Yeah, I don't know.
No,
I don't have new things to say.
It is not like this.
No.
Whenever the non-primary attributes they are dependent on the primary key, they should depend in the whole primary key, not apart from this. This is why in the definition they use the word fully functional dependent, which means that non-primary attribute cannot depend in a part of the primary key. They should depend in the whole primary key. This is the key point here.
Right.
But still they can depend in each other as a non-primary, like what happened in the second example. So non-primary still can dependent on each other, and this is allowed. But if they are going to depend in the primary key, they should depend in the whole primary key, not on a part in the primary key.
Right, but that's the same thing here, right? Because the primary key is only has one candidate.
One attribute, yeah. So in this case, there is no more than one attribute in the primary key to violate the sequence.
Right.
Because in this case, they are going to dependent whenever their relationship with the primary key as a whole, because they can't depend on a part of it, because there is no part of it to be dependent on.
Yeah.
Okay, let's go to the third normalization. The third normalization talk about transitively, non-transitively, which means that all primary key should depend in the all primary key, all non-primary attribute should depend in the primary key as a whole, fully function dependent, and directly non-transitively. Okay, wow. So I can say it in other words. I can say that to be third should be first, second. If it is not second, then it is not third. First condition. Second condition, or take an example here. Second condition, after it is being second, is that there is no relationship between non-primary. Because if there is a relationship between non-primary, then one of the non-primary is transitively related to the primary key, not directly. Before I go to this example, I can go here. So we said it is second. That's good. To be third, we have two conditions. First, second, this is the first condition, plus another condition. The other conditions say that the non-primary should depend directly, fully in the primary, not transitively, which means that no dependencies between non-primary. So it should be second. I can formulate it in a more simpler way. It should be second, this is the first, plus no relationship between non-primary. Here we have these two non-primary related to this also non-primary. They are non-primary, non-primary, non-primary. Now it violates third normalization, because if this dependent on this and this dependent on this, so both of them, the DNAME and DMGR SSN, they will depend on SSN transitively, not directly, because they have a relationship with other non-primary. So in a very simple word, to be third normalization, first should be second, plus no relationship between non-primary attributes themselves. Because if there is a relationship between non-primary attribute, then they will be related to the primary key transitively, not directly. However, third normalization said they will be fully, like the second, and directly. So again, I say it in an easy way, should be second plus no relationship between non-primary attribute. Example here. So here we have here the primary key course semester as a primary key. And we have here this non-primary. Let's study dependencies. Let's see dependencies, what we have dependency here. So we can say that place, let's start from this. Place 100, 100, give us 332, 332. 200, 495. 150, 332. And 12242. So do you believe that we have here dependency? This gives this. What do you think? Before we go to the third number, I'm just double checking dependencies. Can we say that number of place give teacher ID? Yes, no. To have this is as a function dependency mean that the X part should be related to at most one value in the Y part. So 100 related to 332 and also 332. 200, 495. 150, 332. And 120, 242. So I think so this gives this, because for especially when we have a duplication, it's always related to the same value. So what about this and this? Do we have here a relationship? So 332, Mr. Jones, 332, Mr. Jones, 495, Mr. Bentley, 332, Mr. Jones. So always So always 332 is always related to the same value. So I can say that we have here another function dependency. This is, I can name it FD1, and this is FD2. Now, let's see if, so this is a primary key, it should give the other, no need to double check. So now, I have a problem with this. It can, first, it is second. What second say? That no non-primary can be related to apart from the primary key. Okay, let's see if course related to place or teacher ID or teacher name. 2001 give us 100. 2001 give us 100. 2002 give 200. This is violate 2002 150. So this is doesn't exist. Let's check now this course ID, teacher ID. I'm checking if a part of the primary key is related to a non-primary. In this case, it is not anymore second. Before, I will not check third before I check second. So course and teacher ID, I have 2001 related to 332. Let's say 202. 202, some related to 495, and the 202 also related to 332. So in this case, no dependency. Because if there is a dependency, then X value, like this, should be related to one value. Let's see course teacher name. So the same scenario here, 202 related to Mr. Bentley, the same value is related to another value. So there is no dependency between course and any of these attributes. Let's check semester. 2019, 100, and 2019, 200. So the same value related to different value, X and Y. In this case, no dependency. Let's check this. 2019-332, 2019-4195. It is no function dependency because the same value related to different value. Let's check this. Semester and Mr. So 2019, Mr. Jones. 2019, Mr. Bentley. No dependency. So there is no part of the primary key that related to a non-primary attribute. Only non-primary related to each other. But in this case, it is second, because the second say all non-primary attributes should be related to primary key directly. Fully, sorry, not directly, fully. Which means that no part of the primary key can be related to non-primary, which is the case here. The course is not related to anyone, the semester is not related to anyone. In this case, it is second. However, it is not third, because third said it should be two conditions. To be third, we should have two conditions. The second normalization, this is the first one. Second condition, no dependencies, it's easy one. No dependencies, again, no dependencies between non-primary attribute. Because if there is a dependency, then now the non-primary, they are not directly related to the primary key. They are transitively related. So, and this is the case, that we have a dependency between a non-primary attribute. And this is violate. How we can transfer this? We can transfer it by decomposing the attributes that they have some function dependency violation. In this case, I have this, teacher ID and teacher name. I can put it here. And also, I have this, I can put it here. And also, I put this here just to make this connection. This related to this and this related to this in this case. So I can decompose it in this way. Now, this is related to this. And this is, if I don't have a non-primary, by the way, all are primary here. And here are related to this. Now I don't have in any table, in the new tables, a non-primary attribute related to each other. So the new table, they are third normalization. Any questions so far? Josh, I'm not hearing your voice. I'm got accustomed to hear your voice always.
Hi.
Go ahead. Do you have any question, Josh?
Nope, this all makes sense. I just went to the
So
washroom.
if I will give you the mic,
one, so.
if I give you the mic now, can you define again what is second and third normalization?
Sure. Did you want me to do it right now?
Yeah.
Okay. For the second one, basically, it's all dependent on the primary key. We don't really care about the other attributes. We're just trying to figure out, hey, is there a relationship with the entire primary key with the rest of the attributes? If there's ever any sort of violation, it's going to be if only part of the primary key is related to one of the attributes that is not a primary attribute. That'll cause a violation, and then that's not 2NF and automatically not 3NF. So then the third normal form, basically, it's an extension of that. If it's second normal form, we can check for third normal form. And then third normal form is there a relationship between a non-prime attribute and other attributes where it is not, those other attributes are not related to the primary key directly? So is it a transitive relationship?
So So we will double check the relationship between non-primary attributes themselves. That's correct?
Yes.
Perfect. You did it better than me. You should take my place.
That's okay.
Okay, thank you so much. This is, I think so the first normalization, as we said, no multi-value attribute or nested relation should be there. And the second and third, as we have already discussed with Josh. Sometimes the definition, I'm trying my best, the definition in the book somehow ambiguous. It's not easy to understand. I'm trying my best to have a more simpler definition that you can understand it better. So now we will go to a group work exercise. Before we continue with the third, fourth, and the BCNF, I think so it's good that we can practice this. Please, can you take a screenshot of this question? So please, all of you take a screenshot. And now we will go to a breaking room where I will give you 10 minutes or maximum 15 minutes to discuss the solution without having me. And then we will be back to the main room to discuss the solution for this. Are you ready for this? So I will break you down to different rooms. Please take screenshot about this because I think so you don't have this in the version that you have it. So each one of you, please take a screenshot about the question. So just I'm closing the old room, so I will go automatically. Let's make it 6 rooms. You are in the main room, Josh.
Oh, hello.
Hi. Just I'm closing the whole to be sure that all we are here. Okay. So let's discuss a solution for this. I think so. Most of you have your privacy to discuss it internally in a group without having me as a tough person discussing with you there. So, so anyone want to start a discussion here? Okay, we have a Josh. Anybody else also? Okay, Josh, go ahead.
Okay. Did you want me to share my screen for this?
You can, yeah, go ahead.
So this is what my group and I did. So we went through and figured out, okay, so first things first was we labeled our primary key, which was a combination of the prime attributes, customer ID and order ID. And then
Okay.
we labeled our relationships. So we started by figuring out, hey, this is the customer ID is related to the customer name because 101 refers to Adam, and then 102 Alex, 103 Stuart. So we're like, okay, there's a relationship here, FD1. And then we found order ID isn't really related to any of this. So we were like, okay, that's a problem right there. And we realized, okay, well, order ID is related to the order name and the sale detail to some extent. So they're all increments of 1. So that's why we have our second relationship. Or I guess that would be second and third, but regardless. We realized that the primary key isn't acting together, I guess you could say. So we had to split this table. Now we have our customer ID with customer name, which is our relationship.
So before we'll go to the second normalization, the first question was establish all of these. You have some of them. The second one was, is it first normalization? Yes, no. First normalization.
Yes, it is
What?
the first normalization because it doesn't have any multi-valued attributes.
Okay.
And then the relationship does violate the second normal form as it says here. So to put it in
Why?
the second normal form.
Why it is violated?
So the reason it violates is because over here we have our primary key. So this primary attribute relates to customer name on its own. If we had order ID also related to the customer name, this part would work, and then we'd have to have customer ID related to these as well.
So we have a non-primary attribute who is related to a part of the primary key, not the whole primary key.
Mm-hmm.
Because it's not, as you said, customer name related to customer ID. And the customer ID, it is not a primary key, it is apart from the primary key. And now there is a violation. And we have another violation with the order ID and customer and order name and says yes. So how you did it? So you divided into both tables like this?
Yeah.
Okay, but okay, so FD2 and FD3, you put it in a table. Okay, sometimes we need to add another table. It depends about the whole database because to keep them all as a table related to each other, because the final database schema should not be disconnected.
Mm-hmm.
But this depends because sometimes you will have the table, the first table you have it now is related to a third table already. And this third table related to the second. But it depends again. But sometimes if you can feel that you created a table that also will connect them, if we don't have this, it will be good to do it.
Okay. I felt that we could split it into two tables. So we have our tables with the customer ID and the customer name relationship. And then our order ID was our second table, which is related to the order name and the sale detail. And then this is... Oh.
Yeah. Go ahead.
I was just going to say, since this is a one-to-many relationship, so this is the one, this is the many, I included the foreign key, which is the customer ID.
So you put the customer ID, but now you have a problem since the customer ID has now...
So this is my foreign key.
The customer ID, because I'm not checking, I have to zoom it. Just give me 1 second.
Okay.
No, it's better. Yeah. So you have now the order ID and the customer ID in the same table.
Yes,
And-
so this is my foreign key because I realized that, hey, there can be multiple orders per customer. So I added
But-
a foreign key. I don't know if that was okay to do.
Yeah, but no, it doesn't work because the order ID. Wait, the order ID will give customer ID 11101, but maybe this can work. So you have the same customer have more than one order. So 101, yes, this can work also. Let me double check it. We want to be sure that there is the order ID will give customer ID also and sales and order name as a whole. Is it apply here to have this as an order ID?
Sorry, can you
Okay.
repeat that?
Yeah. We should be sure that order ID now is a second table. The order ID is a primary key. Is it correct?
Yes, exactly.
So the primary key should implement the all others. So we should have order ID give order name, sales detail, and customer ID. Does it this satisfy here?
I believe
Because-
so, yes.
Because we thought that and to say it is a primary key means that all non-primary key depend fully functional on this, so they should depend on it on this. So order ID, let us check it. Order ID 10, order 1, sales 1, 111, order ID 2, sales 2. So it give all other, no duplication. Yeah, it works. That's correct. Yeah, that's correct. So
Okay.
now you have it as a second normalization. That's correct. That's correct solution. Yeah.
Okay. I got worried for a second. But yeah, my reasoning is just that the first table, we have our customer ID, which is with our customer name. And then order ID, I split it up with the order name and the sale detail. And then I realized that, hey, we have a one-to-many relationship here because one customer can have multiple orders. So then I just put this as the foreign key. And that was the argument for that. So yeah, that's it.
Yeah, perfect.
Okay.
Yeah, you can do it like this. I have another solution, but maybe your solution is also not maybe it's correct, and maybe it's better from my solution. Let me share yours. Mine, sorry.
Okay, I'll stop sharing.
So here, so as if we go to the FDs, for me, the same what Josh and his group has already worked on it. So I believe that we have a custom ID, order ID gives the other all because it is a primary key. So we have the primary key here, as we said, both of them. So by default, as a primary key, will give the whole others as a primary key. So here we have customer ID already gives others. Now, customer ID, as Josh has already said, it gives customer name. And there is an order ID, give an order name, and order ID give sales ID detail. And you can say also order ID give both at the same time. So the second question is first normalization, yes, because we don't have any multi-value attribute. It violates second normalization. Why? Again, the definition of the second normalization say that all non-primary attributes should be fully function dependent on the primary key. There is no dependency between non-primary. Who's non-primary? This is non-primary, this is non-primary, this is non-primary. And this is a primary, and this is primary. They non-primary should be fully function dependent on the primary key. So they cannot depend on a part of the primary key. They should depend in the whole primary key. So in this case, since we have a customer name dependent, for example, in customer ID only, not in customer ID and order ID at the same time. So this violate. This function depends violate. And we have now Do we have here, we can say have 2 or 3 here violates. This violate also because this dependent on a part, not in both of them. And this also, and if we take it as a whole, is a 2 also dependent on this. So all this violate the function dependencies. How I can decompose it? By getting rid about who violate and keep who's not violate with each other. So I can have a table like first table can be customer ID, customer name as a table. This is the same as Josh has already. This is a table. And I did an order ID says ID customer ID as a table. Customer order ID and sorry, order ID sales detail, order ID, sales detail, and customer ID as a table. And then I make another table, I say it order ID and order name. Josh, you put this as here, is it correct?
Yep.
So this can be okay since we have here only the order ID as a one primary key in this case. And Josh used this as a foreign key. Also, this is correct. So either you can put it both here like this, or as Josh has already done, making them 2 tables. Maybe this decomposition will be more oriented to third normalization, but what Josh has already done is correct also because having the order name here. But wait, Josh, do we have the order name and the sales detail? They have a relationship between each other? Because you put them in the same
Yes,
table.
they have a relationship between each other, but since we're only doing the second normalization, I assume
Yeah, that's
this
good.
will be fine.
That's good. That's good. You are correct. Because we, in the second normalization, we should consider the relationship between non-primary and the primary, but not the relationship within the same table. So what Josh has already done can be second, that's correct, but it violates the third in this case. But I think so what I have already done in this case, it also will apply for the second and the third in this case. Any questions so far about this? Kura, I want to hear you. Kura,
Hi, good
how are
morning.
you? How are the
I'm
kids
good.
now? How is your kids?
They're in school preparing
That's
for
good. So
trick or treat.
you have time to concentrate with us. Okay, so Kura, tell me. So do you have any questions so far?
None for now.
Sure.
Yep.
Okay. Thank you. I will ask another one about this. Who will be Paramveer? Paramveer. Are you here, Paramveer?
Yeah.
Do you have any questions so far?
Right now.
Sure.
Yes. Yeah.
Yeah. Can I ask you?
Yeah.
Are you sure about it?
Yeah.
Okay, thank you. So I will not ask you.
Right.
Okay, thank you.
Thank you.
Anyone has any question? I know it's not an easy topic because it somehow talk about more about the rules and restrictions, but you should know about it. We still have 2, and we will dump on this today. So next time we will have, and I will publish the assignment during this week. I will give you 1 week, and the assignment will be based on normalization. So prepare yourself. You will have an assignment about normalization. It will be our second assignment. It will be about normalization. So maybe the deadline is a syllable. Because about maybe we shift everything. So the deadline, no, its deadlines is not anymore accurate. But I will publish the assignment after we finish this lecture. It will be in normalization. And so you will have another opportunity to practice more. And later, like I always do, I will share you a sample solution for assignment later. Okay, BCNF. Just a recall about what we have already. So candidate key. And there we have something, we name it primary key. So we have more than one candidate key. Prime attribute means that member of some of the candidate key. And a primary key, we can see it as a minimum or candidate key. And non-primary attribute, they are not part from the candidate key. This is what you are just, I'm recalling this. So primary, non-primary attribute. Non-primary mean that attributes that they are not part from the candidate key. Primary attributes, they can be part from the candidate key. Candidate key, which means that it can be later a primary key, or it cannot be a primary key, but it apply about key, which is uniqueness. So now let us discuss BCNF. BCNF is again, like always, so it is another refinement of the third normalization, which means that it add another restriction for this the third one. So the third one so far, what is a third normalization? Third normalization said if we have X, Y, Z, W, and if we have this is a primary key in a table, we said that it is not allowed that we have this is not allowed because it is a part, and this is to be second, and also it is not allowed to have a relationship between non-primary attributes themselves. But the third doesn't say that if it is allowed to have a relationship within the primary key itself or the candidate key itself. Doesn't say this. It say that it work more on the non-primary part, non-key attribute, non-prime attribute. It say that all non-prime attributes they shouldn't have a relationship, and they shouldn't have a relationship internal, and they shouldn't have a relationship with apart from the key. It should have a relationship for the whole primary key, and no relationship within the same non-primary attribute. This is a third normalization. The BCNF add more restrictions saying this, and also no dependency allowed between the attribute within the key itself. So we are talking now about the key themselves. So more restriction. As I said, the upper you will go with a normalization, more restriction you will have. So suppose that the schema that we have here, we have three attributes, city, street, key, and we have this is two as a candidate key, either city and street, or a zip code and street. Both are a candidate key. So no, we don't have a non-primary attribute, so it is third. Because in this table, we have three attributes, city, street, zip code, and all of them, they are primary. So we don't have non-primary to say that non-primary should dependent in the whole and they shouldn't have a relationship, because all what we have here is just primary. So in this case, we can say directly it is third normalization. Go ahead, Josh.
Yeah, I just had a quick question because on the slide here it says it drops one of the restrictions of a non-key attribute. So
yeah, because the
it
third
adds restrictions, but it also drops a restriction.
No, we are talking not about BCNF, we are talking about the third normalization.
Oh, okay.
The third normalization drops the restriction between non-key, between which you said that about the third normalization, in which it drops the restriction of non-key attributes from the third normalization form. Yeah, here we are talking more about you are asking about the third normalization of BCNF, just to be understand more about your question.
I'm just talking about BCNF because I'm just looking at the first thing on the slides here.
Okay, BCNF, yes. In this case, it consider more the key, the relationship between non-primary, between the primary, and doesn't consider the relationship between it's not an easy one. The BCNF, it considers a relationship between the primary, and it doesn't care for about non-key attributes from which is in the third normalization.
So would it be kind of like an extension of the second normalization then?
Yes, you can say this, but it is more restricted in a way that also it considers the third normalization. But yes, to be BCNF doesn't mean to have a third normalization, by the way. But to be forced now, we have to consider the third. So yes, or to consider BCNF in this case, sorry. Yes, it can be said as an extension to the second, because it should be second in this case. However, the BCNF, we can say it is a more restricted, because in the third normalization, we're talking about non-primary. Here, we're talking about the primary themselves. Also, no relationship would be here. Not maybe also, I don't have to use a word. But we talk about there is no relationship within the primary key in this case. Yes, so it is an extension to the second, not to the third. This is why I didn't say that it should be third first. I didn't say this, but I said it is more restricted because to consider non-primary dependency is less restricted, but to consider primary to have no relationship, which is more restricted now. You got it, Josh?
So, yeah, I got that. So what we're saying is that there can be relationships between non-primary attributes. Is that what we're saying? Like, is that okay for a BCNF then?
Yeah, it can be. That's correct.
Okay. Sounds good.
Yeah. So, but now when you go here about this, about BCNF here in this case, so we said there is, suppose we have dependency between the key now, which is in this case, we have between city, street, and zip code. And also we have between zip code and city. So now we have a relationship between the candidate key themselves. Here, this violate BCNF. Again, it doesn't mean that it should be third normalization. We are not saying this. But this is a case where it is a third, but it is not BCNF. But it doesn't mean that to be a BCNF should be a third. No. Based on the discussion that we have it now with Josh, so the BCNF will concentrate in the primary key or candidate key. It doesn't care for the non-primary one. So, however, the third normalization, it considers the relationship between non-primary. There is no relationship between them in this case. So, like all what I have to do is that this is another example where we have another schema. We have the candidate key movie title person name, and we have another candidate key movie ID and person name. So all of this is a primary attribute, and this is non-primary attribute. So here we can see also, it can see that it is both role and payment dot depend on both candidate key directly, non-transitively. Suppose we have this case, so it is a third normalization. However, we have a movie ID and movie title that they have movie ID and movie title, which is both of them, they are primary. And they have dependency. So this is violate BCNF in this case. So now what we are going to do in this case, like always, we have to make a decomposition to get rid about violation. So the violation was in the example one that we have, if you remember, we said here we have dependency between city, street, and zip code and city. So I did, if we make the first decomposition, so we have a zip code and the street as a one table, and we have a city and the street another table. I make this because I have to get rid between city and zip code because I make a violation. The problem now, if I do this, I make a loss of this relation because this dependency already exists. And normally when we make what we name it as decomposition in the third and the second, that we always consider that to take attributes that they have the same dependency in the same table. But here I lost one of the relationships that I believe that this relationship should be considered. So in this case, I name this decomposition as a lossy one or a loss of relations. If I will go, for example, to another one, I make a zip code street and a zip code city. But in this case, I have to change here in this table. I'm not considering it anymore as apart from the key because it's not anymore key here. So this also works in this case, and I have preserved this relationship. But now city here is not anymore part of the key or candidate key here in this case. If we go to example 2, this is the first decomposition here. So we have this as a candidate key. So we put this as with a person name. And since we have a problem between this movie title, I put it movie title with a person name again. So now we lost this. But if we return this again, and we need to have a movie title as apart from the candidate key, if we need it, based on our structure, now we have this returning back. So now we have two options. Either we will go to this one, decomposition, and this is okay, no violation, or we keep this decomposition, but we need to consider this as a candidate key. If you consider this a candidate key, now we have this relationship back, returned back. In this case, if we will consider this as a relation, is this relation, this key, this movie title as apart from the candidate key, then we didn't do our BCNF in a correct way. So now, if I have to keep the optimal BCNF, I have to go to this one. And if I go to this one, then I lost part of the relationship I have it. This opened a discussion that there are some decomposition that where we said it is lossless or it is loosey. It's lossless, which means I didn't use I didn't lost any dependency relationship. And in this case, if I have to go, for example, like here, to BCNF, typical BCNF, and I have no violation for BCNF here. In this case, it is a loosey one. So maybe I shouldn't consider BCNF here, I should consider third normalization. Because as we said, when I will go from the second normalization, I have either go to the third or go BCNF. Third, talk more about the relationship between non-primary attribute, and the BCNF, it's more restricted, talk about the relationship at what work about primary attribute. But sometimes if I have to consider this as a key for me, that the relationship of primary attributes shouldn't have a relationship, and I have to make a decomposition, then I will lose some of the relationship between the attributes. So in this case, maybe the BCNF, it is not the optimal to do it. We have to go to the third normalization, where I have to concentrate only in the non-primary attribute, but don't consider the relationship between the primary key attribute in this case. Again, in this case, it would be third normalization made better than BCNF in some cases. You should have your own decomposition. I believe that we should keep all relationships, so all attributes that they have function dependence between each other should be in the same table. So if I see that BCNF will make some loosey for the dependencies, I shouldn't consider it, and I keep considering third normalization only in this case. So any question about this? So if you compare it, I can say that third normalization and BCNF are not the same, especially in this condition where we have a table has more than one more candidate. Because if it has only one candidate, so in this case, there is no relationship can be, and at least two candidates are composed of more than one attribute. Because if I have only one candidate and have only one attribute, so in this case, there is no relationship between them to be considered. So BCNF here has no sense to use it. And we should have these cases where we have a more candidate key, and we have a relationship, and we have a composite candidate key, share some attribute in this case, to see the difference between the third normalization, BCNF, and to choose which one is the better comparing to the other in this case. So now the last one is today is the forced normalization. The forced normalization said that we should eliminate independency thesis between columns themselves. Okay, let's see what I mean by here. So to be forced, it should be first BCNF here. Okay, to be forced, it should be BCNF here. Some people consider to be third normalization, but most of the references say, okay, we should consider it as BCNF because BCNF is more restricted. To go to the false, we should be considered as a BCNF first. And a relation giving no non-trivial multi-value dependency, what does it mean? Let's take an example. So here we have, this is as a schema, movie name, screening city, and genre. And the primary key is a hold. All of them, they are primary key here. So all columns are part of the only candidate key. And we have only one candidate key. We don't have more than one candidate key, just one candidate key. And there is no relationship between them in this case. No relationship between different value from different candidate key. We have only one candidate key, no dependency between the attributes, or no dependency. So it is a BCNF. However, it is a BCNF. However, many movie can have the same genre. Many movie can have the same genre, like here. And many cities have the same movie. Let's see this. So many cities have the same movie. Let's take a city. Where is the city here? Los Angeles. Or let's say take New York, for example. New York have hard code, and New York also have another one, which is code warrior. So as if it is one-to-many relationship. We are not talking about tables. We are talking about the relationship about the attributes themselves. So the same attribute have more than one relation. Like New York hardcover, New York code warrior, the same New York. It can be also like between other attributes. In this case, this is violate force normalization. Why? Because force normalization itself, it is BCNF, which is no dependencies between candidate key. And here we don't have this. Plus, also we shouldn't have one-to-many relationship between them. Josh, I will answer you. Just let me take another example and we'll be with you. So this here, another example here, we have a manager, child, employee. So the primary key, we have only one primary key and only one candidate key with no dependencies in this case. So we have a manager, child, employee. However, each manager, like for example, has more than one employee. Like Marie here has Jane, and Marie also have Adam. So, and in this case, this is violate force normalization. Again, force normalization, it's more restricted. Say also it should be one-to-one relationship. That this gives this only, and this gives this only. We shouldn't have between them something that violates this is force normalization, but having, as we said, a given relation contains no non-trivial multi-value dependencies, which means that again, I can say it in a more simple word, there is no many-to-one relationship between columns in this case. Go ahead, Josh, before we go to good decomposition. Ask me what you want to ask. Josh.
I think it's fine. It was just about screening city being a multi-valued attribute in this case, but that's it.
We are not talking about multi-value attribute as we have already said before about multi-value attribute. We are talking about a multi-value relationship, not to be differentiate between this. Because the word multi-value attribute is what we talked about it later, like the location. Here we are talking, we don't have a multi-value relationship, which means that we don't have one-to-many relationship between the attributes themselves. So the same value, like here, Marie, is related to different values with other attribute or column in this case. You got it?
Yep.
So I always want to decompose it in this case, which is to two different tables in this case, where maybe this is mistake here. It should be force normalization, not third. So it is a type of mistake here. So we will decompose it two different tables where the tables that they have this one-to-many relationship, we put it in different tables as we did here. And this is another one here also where we will have, since we put a table where we will have manager and the child and manager and in this case, which means in this case can supervise. We are talking about supervising here. In this case, we do in a way that we will make all this decomposition and as we did before in the force normalization. For the fifth normalization, we will not discuss it in this course. Just I want to give you about a hint because it is more idealistic. It's not being used, which talk about whenever you will have, it should be forced, and it has a loosely decomposition, which means that you are not able to decompose more without losing any relation. Again, you are not able to decompose more without losing. So you can say, now I have a fourth, and if I can't decompose more without losing any information, I have fifths. And it's a very idealistic one. So this is why I will stop at the fourth one. I will not go to more about this in this case. I know that so much information today about normalization, but we should be aware in this course about first, second, third, and the fourth, and the BCNF. So we still have 5 minutes. If you have anyone have a question, go ahead and ask me. Samran Pret.
Yes, sir. Fine.
Do you have any question for me today?
Not today. No.
Sure.
Yeah.
Can I ask you?
I'll try to answer.
No, I'm okay with it. I will not ask you.
Okay.
Sanyam Sharma. Sanyam. Are you here, Sanyam? Sanyam, it seems that he is not or she is not here. I don't know. This name is a boy or a girl. Sanyam, can you hear us? Or maybe you write something in the chat. So we don't have this. So I think, Ayman, you are the last person today. You're always A with A. So always A, people start with A. It's always a problem for them because my name, when you write it in my mother tongue, also it was at the first alphabet. So I hate myself because always the instructor, the teacher has a list of the names and my name will be in the first. And then always I'll be the first one to be asked. You have the same situation. I feel sorry for you.
Yeah, it's okay.
Do you have any question for me today?
No. I might probably have to watch your lecture again just to understand it more.
Okay, and I will I will upload the lecture after sometimes there are some typo mistakes. I have to revise it and then consider the upload lecture in this case. And also I will send you an assignment too, and also I will distribute to different groups for the project that we will discuss it next lecture. Navipun, go ahead.
Hello,
Navipun.
Professor.
Yeah.
Yeah, so just want to make sure that if we only have one primary key, so we will pass the first two normal form, right?
Yeah, the first normal doesn't talk about dependencies. It's very special. The first normal talk more about if we have a multi-value attribute, yes, no. And if we have the primary key with one value, with one attribute, and then by default it is a second normalization, because what violates the second normalization is whenever you have a non-primary related to a part of this, not as a whole. But since it is only one attribute, so it cannot be different part. So by default, it will be second normalization.
Okay, thank you.
Sure. Josh, go ahead.
Yeah, I was just so for fourth normal form, we're just doing BCNF and then we take into account data redundancy is what we're doing, right?
Yeah, that's correct.
Okay, sounds good.
Okay, guys, to leave today, like always, I need 10 thumbs up or I will stay here. It was, I'm sorry. It was a very long lecture for today, so I'm sorry for this. I wish you have a nice day and week, the whole week, and see you next week. Take care all.
Thank you.
Thank you, Prof.
Thank you to be here.
Can you move your Can you move your 4:30 class next semester to start an hour later so I don't have time conflicts?
You mean which class?
4:30 next semester. It starts at 12:10, but I need it to start at 1.
I have to double check. I'm not sure about if we can change something in the schedule. I hope that we can do this.
Yeah, I figured you would not be able to, but I just ask anyway.
Okay. No, to be honest, I will try because you have already asked.
Yeah, because if it's at 1 o'clock, that that means I can take Physics 112 lab that ends at 12 o'clock or 12:30.
Ew,
Okay,
physics 112.
I know.
Yeah, comp 430. If you